Redox reactions involve reduction and oxidation. In fact, as we will see, reduction and oxidation always go together, since if a species is reduced, another species must be oxidized. Oxidation is the loss of electrons. An iron 2+ ion is oxidized when it loses an electron to form an iron 3+ ion. Oxidation can also be defined as an increase in oxidation number. In this case, the iron 2+ ion, being a simple ion, has an oxidation number with the value of its charge at +2, and the iron 3+ ion has an oxidation number of +3. In this reaction, the iron's oxidation number has increased, and so the iron has been oxidized. Reduction is the gain of electrons. When a bromine molecule gains 2 electrons to form bromide ions, the bromine has been reduced. Reduction can also be said to be a decrease in oxidation number. In this case, the bromine in the bromine molecule starts with an oxidation number of 0, since it is an element that is not combined with another element. It ends up as a bromide ion, and being a simple ion, has the oxidation number equivalent to its charge at -1. And consequently here, the bromine has been reduced. These two equations are known as half equations, and we may add together a reduction half equation and an oxidation half equation to give an overall ionic equation for the redox reaction. Before we add half equations, however, we must ensure the number of electrons in each half equation is the same. In this case, we multiply the equation involving the oxidation of iron 2+ by 2. Now the two half equations have the same number of electrons involved, we can add them together. Because we have the same number of electrons on both sides of the final equation, these cancel. In this reaction, we have an iron 2+ ion being oxidized to an iron 3+ ion, and the bromine is oxidizing the iron, so we say bromine is the oxidizing agent. The bromine is oxidizing the iron 2+ ion, but it itself is reduced. Consequently, the iron 2+ ion is reducing the bromine, and so the iron 2+ ion is the reducing agent. Oxidizing agents oxidize other species, but are themselves reduced. Reducing agents reduce other species, but are themselves oxidized. In this example, we are given two half equations, and we need to construct the overall ionic equation for the redox reaction. The oxidation half equation is as follows, with iodide being oxidized to iodine and electrons are lost. The reduction half equation involves the manganate 7 ion being reduced to the manganese 2+ ion and water, and electrons are gained. Before we add the half equations, we must first make sure they both involve the same number of electrons. In the top equation, we have 5 electrons involved, and in the bottom we have 2. We need to find a common multiple of 5 and 2, which is 10, and so if we multiply the top equation by 2 and the bottom equation by 5, we will end up with 10 electrons in both equations. When we multiply the top equation by 2, we get 2MnO4- plus 16H plus 10 electrons goes to 2Mn2+ plus 8H2O. And now, when we multiply the other half equation by 5, we get 10I- going to 5I2, plus 10 electrons. Now we can add them together, and we can cancel the 10 electrons that appear on both sides.